Welcome everybody. I hope you would have seen this Olympiad question and the solution to this question, but apparently I'm of the opinion that the solution dealt in erstwhile videos is not the appropriate technique, or even in fact the way the check has been performed, right, by using approximation, that could be much avoided. So I would like to show you an alternative approach to solve this particular question. And if you like, you can accept this and apply it into your daily routine, so problem solving. So having mentioned this, what I would do is I would like to bring this 130 to the left hand side. So I can now rewrite 8 raised to the power of x positive 2 raised to the power of x negative 130 is equal to 0. Now we know that 8 can be rewritten as 2 raised to the power of 3, and also the entire system using this representation for 8. So let me do that. So this is going to be 2 raised to the power of 3 raised to the power of x positive 2 raised to the power of x negative 130 is equal to 0. Now a raised to the power of m, the whole raised to the power of n, can be rewritten as a raised to the power of n, the whole raised to the power of m. And we can also simultaneously rewrite it as a raised to the power of n times m, and so on and so forth. So that is from the law of indices. So I would be utilizing this, that is flipping the exponents. So this is going to be 2 raised to the power of x, the whole raised to the power of 3, positive 2 raised to the power of x, negative. Now 130, I'm going to rewrite it as negative 125. Followed by negative 5 is equal to 0. Fair enough, right? Negative 125 added with negative 5 would give me negative 12330. Now, having got that out of the way, what I wish to do is I would like to take, let 2 raised to the power of x be some t. So this is going to be t cubed followed by positive t negative 125 negative 5 is equal to 0. I will club these two together. So that would mean I have t cubed negative 125 as one quantity and t negative 5 equal to 0 as another quantity. Now this is actually a cubed negative b cubed, which can be rewritten as a negative b times a squared positive ab positive b squared. So that is a formula I will be using. So to employ this formula, I need to have b cubed here, but I've got 125. So what I would do is I will write this as t cubed negative 5 cubed followed by t negative 5, and that has to be equated to 0. Now, since I already have your a cubed negative b cubed form, let me use this formula. So this is going to be t negative 5 times t squared positive 5 times t positive 5 squared, that's going to be 25, followed by t negative 5 is equal to 0. So this is what I've got. So t negative 5, I can take it out. If I were to do that, I would get t squared positive 5 times t positive 25. Over here, it's going to be positive 1 is equal to 0, right? So this is going to be t negative 5 times t squared positive 5 times t positive 25 added with 1 would give me 26 is equal to 0. So from here, t negative 5 is equal to 0. And or I should say t squared positive 5 times t positive 26 is equal to 0. Now if the question is requiring us to get the values of x for which x element of real number, then this will be the only solution, because if I were to use this is going to be t is equal to negative 5 plus or minus root of 5 squared, that's 25, negative 4 times of 26, so 6 4s are 24, 2 4 2s are 8, 9, 10, divided by 2 times of a is 1. So this is going to be a complex root, right? So as I mentioned to you, if their focus is only to solve x for x being element of real number, then this will be the only solution. So t is equal to 5 will be the only solution, but the value of t is taken to be as 2 raised to the power of x, right? So you have 2 raised to the power of x is equal to 5, and to extract the value of 5, what I will do is I would be taking log to the base 2 both sides. So if I were to do that, I would have log 2 raised to the power of x to the base 2 is equal to log 5 to the base 2, and this in turn can be rewritten as x times log 2 to the base 2 is equal to log 5 to the base 2. Now log 2 to the base 2, this is going to be equal to 1, this entire thing, because of the fact that log a to the base a is equal to 1. So this is going to be x is equal to log 5 to the base 2. So this is the real value, right? So as I mentioned to you, this has to be dropped. Okay, we are dropping this owing to the fact that it is producing as a complex root. Now the much important question is, how are we going to make this check? That is the important thing. Okay, alright, we have got x value to be as log 5 to the base 2. Now can we place it in the original system, which is 8 raised to the power of x positive 2 raised to the power of x is equal to 130. Can I substitute it and show that left hand side is equal to right hand side? Yes, we can do that. So what I'm going to do is I'm going to take x value and substitute it here. So this is going to be log 5 to the base 2 positive. This is in place of x I'm substituting. So let me just write this like this: 2 raised to the power of log 5 to the base 2. So this has to be equal to the right hand side. Now let me simplify this. 8, I can rewrite 8 as 2 raised to the power of 3, and apparently this is the index, right? So this is going to be log 5 to the base 2 positive 2 times of log 5 to the base 2. Now there is a formula. What is the formula? A times log b is equal to log of b raised to the power of 8. I can use this formula. So this is going to be equal to 2 raised to the power of log 5 raised to the power of 3. Don't forget the base. So place the base. Positive 2 raised to the power of log 5 to the base 2. Now 5 raised to the power of 3. What is that? That's going to be 125. So this is going to be 2 raised to the power of log 125. As I mentioned to you, place the base. Positive 2 raised to the power of log 5. Place the base. Now there is a formula. There is a property. Now what is the property? Let me state the property. We know that m raised to the power of log x to the base m is equal to x. So this is the all important property in logarithms which we are going to be using. So by this property, what happens? You got 2 raised to the power of log 125 to the base 2 and 2 raised to the power of log 5 to the base 2. So this is going to be equal to 125, and this is going to be equal to 5. 125 added with 5 would give me 130. What is that? That's nothing but our right hand side. So there is no approximation involved in this technique. It's a straightforward utilization of logarithmic property and using some basic algebra to solve this question. I hope you all enjoyed this. Thank you very much.